The third problem with the standard max, as you know, it isn't about recursion, more about being professional in providing and covering all of the different test cases. I wrote my own code, which might not be the best one, but I hope it's clear enough for you to understand it. I divided the function to two parts, myMax and another like hidden myMax function. The myMax role mainly to do more of the checking and the validation that we need to do. The first thing that this function is trying to do here is trying to check if we have at least one element or not. One way to do that without the length function is the unpacking. So I'm trying to unpack the iterable, which is probably an iterable, to the first and the remaining of the items here. Now, if it happened that there's a problem here to divide it, we know that even the first isn't available. So this means the iterable is something that is just empty or doesn't exist. So I'm here raising the first error that at least one argument is expected. Observe here this from none. I didn't mention it in the exceptions section. When you write here from none, if it happened an internal exception here, its error message is going to be hidden. From none here, allow it to that. If you'd like to hide some internal error and just focus on your error, you pass it here. If you remove this line, it's going to show some internal error and also this error. This way we handled the first possible error, which is there is even no arguments at all. Now in the second one, we have a problem. Is it a single item that is iterable or not? If it's iterable, it might be empty. So now let's see. If we are at this stage, we are sure that first exists, but we'd like to check the case of the sub-iterable. Now we have two cases here. If there is a sub-iterable, then we have at least the two arguments. Now we can call internally this myMax with the iterable here again, which will be the same list, but we now are sure that it can be split to two items at least, because there is a first and the remaining of it. If there is no sub-iterable, then we have only single item here, and I would like to check some details about it. The first thing is we should be able to unpack it. We should be able to unpack it because it should be like a list, for example. Now, if we try to do that here, according to the way I am coding it, there might be two different errors that might happen. The first one could happen during the asterisk first itself. The item isn't backable. Let's say someone passed the function with only value like 15. So asterisk first itself is going to fail and probably will give us a type error. So we can make use of this type error if we catch it to tell him that, hey, you are passing object isn't iterable. So this is mainly what happen here if someone tried to pass a single number only. So a single number will come here, it will be in the first, this guy going to be empty, and unpacking 15 is going to fail in a type error. The second case is we actually have something that is iterable. Say we have this case here. So now we can actually unpack it. Very good. So now let's pass whatever we unpacked here to this function here. Now, if we try to send again the iterable here, it's going to try to get the first out of it, which is going to fail in the case of an empty list. It's going to fail in the case of an empty list, and it will generate for us a value error. So if we put a value error here, we can generate an error here. But observe that we has a default value. We has a default value, and this default value should be used only in case of an iterable case. Now, before in some assignments, I told you consider the default to be none, and we don't need to care now about the non-special case. I'm showing here you how to handle the case that what if my default can be none? How can I handle that? We can create a very dummy class here, and this dummy class is going to be used as my initial value. If the default value isn't this dummy value, then we definitely know we have a default value. So the moral of that is here, if we manage to back it, but we fail to get a first element, if we manage to unback it, but we fail to extract element from it, then it will fail here, and we are going to catch it. If we have a default value, we will use it, otherwise we will raise a value error. Once you are done with that, then you handled clearly the three possible cases. such as having only a single zero arguments, or having a single argument that isn't iterable, or having a single argument that is empty without a default value. This way, in a professional way, we covered all of the different cases. Once we are done with that, we are going to return the mymax. Mymax here is going to be returned in two cases. Here, in case of a list, we are going to unpack it by the second function, or here by our mymax function. So let's get into the mymax function. Mymax function now is the easy case of the recursive code. We are going to divide it to the first element and another element. If there are no more iterable, it means that the list has only one item or the items, then we are going just to return it. Otherwise, we compute the max of the remaining items, and now we are going to maximize between two things. There are two cases, either the key is none or not. If the key is none, we shouldn't convert to the items. So direct comparison between the first and the remain. If the key isn't none, then we should compare the key function, not the value themselves. So here I create the values of the key functions, and now comparing key with the key and returning the item based on the key comparison. I know now you have a good idea how the max function is implemented internally, and to get a good sense of how something might be complicated. As an advice, try to think about some of what you use internally, how it might be implemented. I definitely, and any expert, we don't have to think about every function that we use, but you should be skilled enough if you are asked to get some sense how it could be implemented, to know how it could be implemented, and to be able to cover all of the different test cases. That's all.